share the seminar slides again. But basically, it takes something that your student already knows a little bit about and gives them the opportunity to expand that game. And so game-based learning will help increase engagement. It does reinforce core concepts, both in terms of coding, because they are coding within the game, but as well as problem solving and then practical learning, different pieces. It gives students hands-on experience and allows them to foster creativity and have fun while learning, especially starting out in their coding experience. Perfect. If you want to go to the next slide for me. Perfect. So this is just a big overview of our classes and ages, and it's broken down into 3 categories. So it's game-based classes, general age progression, and then Katie Bike core level. So the first one here is Scratch. Generally, we recommend that for students who are aged 7 to 9. 7 isn't here, but students age 7 to 9 will show. And then beginner AI, Roblox, and Minecraft generally can fall between the ages of 10 and 13. So this is really just an informative graphic. It'll keep coming up throughout our meeting today because we'll kind of keep referring back to different pieces. As we talk through things, we'll start talking about things in a chronological order. And so we'll start with students who are very young. So we'll start with our Scratch classes because generally if your student is coming in at the age of 7, we're going to recommend Scratch, and then moving into our core classes. Core classes down at the bottom here. I'll give a quick explanation of those just in case we have some brand new people. Our core classes are basically our foundational classes at the very young ages, core 1A and 1B, and then 2A and 2B. Those classes will be taught in Java blocks, which actually very closely resembles Scratch, except for Java blocks uses Java syntax and then the block-based format, whereas Scratch is an educational language, which is really great for students. And it says run this direction and how many steps or how far in that direction. And so instead of where Java uses the grid coordinate system. And so you would say move X and how far you would like to move X. So in the same context, you're moving something from this space to this direction, this many spaces. And so the concepts will be similar, but within our core levels, you'll start to learn actual Java syntax, which you'll then move into processing and then full on Java code. So as we kind of go through, we can go to the next slide. We're going to start with Scratch. So Scratch provides a super engaging learning environment. It is block-based code. It's created by MIT, so it's really well known. And there's lots of different learning modules and ways to use Scratch. We've had lots of students before they started with us have utilized Scratch, and it's well known, and it's well known for good reason. So if you want to keep going for me, you will to the next. This is our Scratch class. If you'd like to join us for a Scratch class, I will have all of the times in here for our actual presentation. This isn't as important, but we will send out the slides to everyone. So if you wanted to take a look through and you were excited about any of these class offerings, you'll be able to see them in the slideshows. But for kind of this, we'll just kind of skip through the class offering section. Perfect. So along with Scratch, I'm bulked in Core 1A, which is thinking with code. This is what the code will actually look like. It resembles Scratch in that We have different colors for different types of code or different pieces and different chunks. Students will still learn how to organize code, obviously not using indentation, but they'll use the space within their coder. And on the right side there, you'll see the output. And so for younger students, this is still really fun, very flashy and digital, and it allows them to get excited about what they're creating and see something very physical from what they create. So we're going to kind of keep walking through. We're gone Scratch and then Core 1A. So we're kind of 7, 8, 9 years old, and we'll kind of keep going. And this again is the slide for if you wanted to take a Core 1A. We currently have 12-week classes coming up, and those are just starting soon instead of our current semester. 18-week classes are currently on week 5. And so those ones are going well. We can keep moving past this slide. Perfect. So we're kind of back to our progression here. So we've gone through Scratch, which is 7 to 9, and now we're looking at sort of 10 years old and starting to look at Minecraft, Roblox, and classes like that. So we can keep going. Perfect. Going into Core 2, students will still be using this block-based coding system. And this is still very project oriented. And so game-based classes and project-based classes allows students to learn concepts and then put them all together into one big game. Even in Core 2A, students are already learning how to create interactive games where their mouse will interact with the canvas, and then continue to create. And even within this, we've had students go in and further refine games like Flappy Bird or other sorts of fun games. I've spoken to students with uh, very big accomplishments, and a lot of them had started from their parents helping them or sitting down with them and just working through some Scratch problems, which is completely doable even if you're brand new to coding or you're brand new to the whole world of computer science. It's very user friendly and very easy to walk through. Similar with these, you can walk through different projects, and a lot of students get a lot of validation from not only creating the game, but then going further and making it their own by changing colors, adding different pieces. And so it really allows students to use what they're learning, both for projects or for games. So we can keep going, and we'll have another slide for class offerings. So we'll keep going past this. And then we're getting into Minecraft. So Minecraft is a well-known gaming platform where students have the opportunity to build pretty much anything they want. It's a really cool game because it allows the user to create their own experience, which leaves a lot of room for creativity. And within Minecraft, below being able to create whatever you want, they have an educational piece of their game, and you can go within the Minecraft code and make your own modifications. So that means you can make things float or do special things. You can create your own type of object. So it allows students to sort of learn computer science concepts, but learn it within something that's already fun and enjoyable to them, and is a fun way to kind of sneak in the vegetables. Some parents sneak in vegetables once your kid's eating and you want them to eat all of the good food, and sometimes maybe they're picky eaters. So this is a great way to get coding in while kids are already playing a game that they love. So it's really good for students aged 10 to 13. And we'll kind of assume that you have knowledge with Minecraft, but it doesn't assume any knowledge of coding. So it's a really great beginner class. Moving on, we have 2 offerings for that. I'm very excited about it. Beyond that, keep going. Beginner AI is one of our newer classes. AI is such a big scope, and like game-based classes, it can kind of be a tangled web of what's really educationally beneficial or what is AI and where do we start with it. It's really good for kids who want to know more about AI. This class does not teach you how to use ChatGPT or anything like that. It's a Scratch-based class, which is really great for anybody who has no coding experience. And it teaches you how to understand what AI is and how to create AI more so. It's not a full AI class. It's obviously built for 10-year-olds. And so it is teaching you how AI thinks and why it exists, basically. Not necessarily why it exists. That's quite a large question, but it allows for hands-on projects and it's a fun learning experience about AI and can allow for better interaction with AI down the line. So that's a really good opportunity. And it's a great way to introduce things like games and AI in a way that's very beginner friendly and beneficial for a student's learning journey with CS as a whole. And keep going. Perfect. So we've kind of gone through beginner AI, Roblox, Minecraft. We're still within sort of the block-based code, and now we're going to make our segue into Core 3A and 3B using processing, using typed out code instead of block-based code. This is a decent step in the learning journey of any student. And this is a gradual transition for students, which is good because when you're thinking about game-based learning, you're starting off with something that you really enjoy and you have fun with so that you can start to build interest. And this is kind of moving in a more project-based, more of the building the game rather than like playing a game. Even in Minecraft, you're still building within the game to increase gameplay. Processing is a form of Java. It allows us to use this coder interface, which you're seeing on the right here. It compiles the code for students, it produces a console, and it allows students to debug all in the same place without having to download the entire Java language onto your computer. This is really beneficial on a technical side, and so I won't get too far into that. But it allows students to create games like Pong, which is a very well-known game and project for beginners at any level. Even if you go to lots of adult coding programs, a lot of them will have you build out Pong because it's just such a well-known way to teach specific computer science concepts. On the right there, you can see the interactive coder interface. So whenever you run your code, all of that code on the left will create whatever it is in your console. So obviously students have complete control over what they build there, how they build it, making sure that they're debugging it well. And their code on the left, they do start to learn all of the necessary things like keeping your code organized, as well as building these large scale projects and learning how to read all of that code. Obviously, having gone through a game-based class where they've already learned to code, this is a lot more comfortable if they've started with something even like Minecraft or Scratch. It's giving them a direct advantage even as they're kind of moving through core classes. And we'll keep going. Oh, and this is the class offering. So we're going to jump into student cases. We've kind of gone through all of the core 1 through 3, ages 7 through about 13. So if we were to look at all of this and how game-based classes would play into a student's learning journey, we'll start with a student named Joey, and if we'll say he started with us around age 7. His parents would really love to see him competing in USICO or something because a lot of parents, once we get into computer science, USICO is a really well-known, very prestigious competition. And so a lot of parents set that as a goal, which is a really great goal. And so once Joey joins with us, they select the competitions track, which is one of our tracks. It tells us what you would like your student to do, or it tells us what your student is really interested in. You can select multiple tracks, but it allows us to help in creating sort of your student's learning pathway, which is what you'll be looking at here. On the top row, you can see the student age. So Joey started at age 7. And we'll say that he started out in Scratch, which is a really great place to start because you're just a little too young to get into core classes yet. And Scratch is designed for very young students. And then he's moving through core classes all the way until he's 10. And ACSL is a computer science competition, and it's really built for students in grades 3 to 6. We offer like a competition prep course, which is why it's taking up a whole section. So Joey ended up taking that for that semester and then moved to Core 3A. This is all kind of moving through here, going to junior, going 4A, 4B. Each of these would be tailored depending on how well your student's doing. The reason we introduced the competition at such a young age, and even before that, we would have him taking the Beaver Computing Challenge and any other challenges that would fit within his age range. But that one, it doesn't require as much preparation, so it's not listed. But those would help give us an idea of whether or not he really thrives in that environment. And then we'll keep exposing him to different competitions. And then by the time he's about 14, he's able to start working on actual USICO material. USICO is firmly a high school level difficulty test. And so generally we recommend if you are someone who's looking at competitions, if you see here, Scratch already made it in, and then we introduced a different type of learning, which was ACSL. But that all started at a very young age. But every student starting at every different age can have sort of a learning pathway that's adjusted. And a lot of times it will start from a place like Scratch or Minecraft or something that's just very exciting and allows students to get a taste of sort of the power that they can have in creation when they know what they're doing and they know how to communicate with a computer. And we can go to our next student case. This one is a little bit different. And so this is Jenny. She is young, she's 10, and she's interested in computer science, but mainly it's just kind of seeing how it fits in, which is where a lot of people are. And so she starts in Minecraft at 10 because she's already really interested in it. And so from there, she can move into our core classes pretty easily. And then even with her, she can try out all kinds of different classes, like ACSL if she wanted to see if she likes competitions. And then Unity is another really cool class because Unity is a game-based class in some ways, but it's game design. And so students will be able to take on the role of a game designer at a pretty young age after they've finished Core 4A or Core 4B. And all of the games that they enjoy, they can kind of imagine up their own game and really bring life to it, depending on how much time and energy they have to put into their homework. And so that's also a really cool way to express those games that students really love in a very creative, informative way. So beyond these are in here just as kind of a way if you're not sure where to start or where to go. These can be very helpful. You can see in her later years, so 16, 17, later years in high school, not high school, early-ish years in high school. She starts in AI 1 and 2, and those are, AI and machine learning classes, which allow students to create large research projects. So those are also really great to explore down the line. And we'll continue on. Cool. So I did say if anybody would like to ask a question or has a student case that they'd like to go over, if you have a student age and general interests that they'd like to ask about, you can feel free to ask within the chat and I can take a look at those. Or if you have any questions, I did move through the material pretty quickly, but if you have any questions about game-based classes, about how game-based learning affects students or how our progression works or how just progressive curriculum should look, if you are looking at institutions or anything like that, I'm happy to answer any questions. Taking 2B. Very cool. Cool. So we have a student who is 10 years old and taking 2B. Can you go back to the student case slide just so we can look at the
Yeah. On this one?
there. Yeah, we can look right here. So currently we have 2B. So right around 9, 10, perfect. Um, ACS Elementary, which is very good. Game design. Cool. So if we're looking at core, I have to check what's good path for him. Okay, cool. Yeah, Unreal is a really good game engine as well. We use Unity as our primary game design platform. And then we also have a Godot class. They run at opposing semesters. So, Stephanie, your main goal, if you want to hover over Core 4A, Core 4A is going to be the biggest breaking point for most students when it comes to the longer range uh, game design courses because whenever we're looking at computer science education, I always try to describe it as a tool belt because I'm pretty handy and you always have to have a tool belt. No matter what you're doing in life, everybody's got a tool belt. And so sometimes when you're going to work on something and you find that you don't have the tool that you need, it can be frustrating. And so for students, getting to Core 4A will put enough tools in their tool belt for them to successfully get into like Unity or Godot and be able to have creativity and have the tools to build what they want to build. So generally after Core 2B, you can take a game like a game-based class like a Minecraft because that is a really fun and cool class. I know tons of kids who work in Minecraft and make really cool stuff. And allow it can allow your student to have tools within a game that they already love and that can allow them to even become more creative when they come back to coding. So that can be really beneficial for your student if they already like game design. Within Minecraft, you just have so much opportunity for creation in there. And then once you can mod within Minecraft, so you can go even further into it, gives you a lot of creativity. So in the time when he has to learn a lot more of the Java, so going into Core 3A, Core 3B, Core 4A, those three classes will be your next three steps before he can take Unity. And so Minecraft could be a really great option if you want him to have an opportunity to learn more and have something fun and creative that he gets to do while he's doing those more core classes like Core 3A, Core 3B, and Core 4A. But I would say that that would be my my direction to you is take Minecraft if he really loves it. Yeah, so I want to check. Of course, it's still gonna. Yeah, that's a great question, actually. A lot, she said, I also want to check whether Java-based course is still good one, given seems everyone uses Python now and AI can write code now. I love this question. So my answer for anybody who ever is curious about languages, you have a goal, everybody has a goal, or maybe we should think about what the goal is. But with computer science and students, we're thinking about kids, and generally we're thinking about kids between the ages of 8 and 18 years old. Those students are inevitably going to go to high school. The AP Computer Science A exam is taught in Java. And so we've chosen the language of Java because we have Java Blocks, which allows you to learn a real computer science coding language at a very young age. Java is an object-oriented language, just like Python. And Java and Python are both very well-known, very widely used languages. There's debate here and there and everywhere about whether Java or Python is easier to learn. I think that depends on your teacher, your classroom, the content that you're covering, who's teaching it and how. So I think that's the main thing with Python and Java. But the main thing I always tell people to look at is what your use case will be. If you're looking at going into USACO, they accept Java and Python and C++. So there's no real benefit one way or the other. Python can take longer to compile, but I think even now, the USACO does give you some time addition for that. I'm not 100% sure on that. But everyone uses Python now, and AI can write code. What AI cannot do is teach you how to think or how to understand or communicate, which is the other big thing about computer science, just in general, coding and languages. I think it's easy to get caught up in a lot of languages or buzzwords. Minecraft is even a buzzword, Roblox. Those are all really big, well-known companies, and they offer something really cool. So the benefit is not in Minecraft, it's in the fact that they allow you to get into their game and code in there. And just like Java, Python, any of them can be useful if you want to go into AI research. Python is a wonderful language for that. Once you have learned a language to mastery, you could say, like once you understand a language well enough to use it consistently, correctly, and well, then you can comfortably switch to a different language. Computer science languages are not direct correlations to English and other languages. Like if I was trying to speak to someone here in a language that they didn't understand, it's not going to be the same as if you write a void draw function versus a def draw function, which def draw is what you would call it in Python, and then void draw is what you call it in Java. So those are both functions and they're similar. They do the same thing. They just sound or look a little different. And even with every function and loops, arrays, different things like that, they're not all going to have different words, and the logic will still remain. So I think what's most important is making sure that whatever organization or whoever, whatever you're trying to learn, focuses on not just the language, but real computer science topics like how to understand what you're telling the computer, why you're telling it that, so that then you're not trying to down the line make quick fixes or anything like that. So I would say Java-based courses are still really great depending on what your goal is. I've had students who've started in Python and ended up switching to Java, or starting in Java and switching to Python. Languages just kind of depend on what your goal is. Yeah. How old can students learn Python and Java? That's kind of dependent on the student. Every student is different. Generally, we say around 8 or 9 is when our youngest classes will start. Scratch is, I guess you could call it a completely different computer science language because it is an education-based computer science language. And so most students will start learning Scratch. And so they've done their first language switch already at the age of 7 or 8 or 9 sometimes. So students are very elastic in their minds, so they can learn a whole lot. So I would say students around ages 8 and 9 can start learning Python and Java, and we do have both Python and Java classes. Our Python 1 class is going to probably be around like 10 years old. You've kind of have to have a bit of kind of already the ability to like want to do your homework and be kind of self-sufficient. That's the main age requirement there. Last question. Minecraft, how can we differentiate what suits for my kid and tell the difference? Yeah, there's so many offerings for Minecraft. I would say, well, there's self-study options, and then there's like teacher-led options. Obviously, I'm going to recommend our classes first because I love our instructors. And obviously I'm here. But outside of our classes, I would say make sure that it has a structured curriculum and read through that curriculum. It's good to know what they're learning, and generally, even the curriculum that you can see or any structure that they'll let you see, they'll make it very user friendly for you to read. Generally, you'll want to make sure that they're going over real computer science concepts, which they will have to because they will be using code. And then I like to say look for things that build. So you're starting off with something small, like maybe learning how to use a new block or how to create a new block thing, and then looking for pieces that add up to a whole. A lot of students will do well with project-based learning, which is learning different pieces of things and then putting them all together. And so I would look for something that has individual learning modules along with larger projects. That's generally what I would look for. I don't think that you can differentiate always what would suit your student best by doing that. If the place offers auditing, I always recommend auditing a class. We offer that here as well. If you ever want to audit a class, you can just join a class, and I think every place should, just so that your student can sit in both with the instructor or just to see if the class format fits. And then make sure that the level is a good fit. Some students are just miraculously good at Minecraft. They're wizards, and I think that's super awesome. And sometimes classes might not be able to keep up with them. So just make sure that you're at a place where your students really getting a lot of enjoyment from the class, because the more that they enjoy and really like to do something, the more they're going to want to do it and the more they're going to want to explore. So I always say that enjoyment and the joy is what we want to foster so that down the line, they'll also have the same enjoyment and joy for coding, even when Minecraft or the game part isn't there. Those are all really great questions. So thank you, everyone. Mm. Yeah. So our core classes are actually like Java training classes, basically. So they are core Java training, starting with like loops, arrays, functions. And it also goes over there's something called like a Caesar cipher. I don't know if anybody knows what that is, but it teaches students how to create ciphers in computer science, or how computer science is and how computers encrypt things and how to decrypt things. And so it's both learning Java with projects that are based in kind of real world things that you can understand. So it is core fundamental Java courses. I'm gonna grab a sip. Also, it is 9:42, and this is our information here on the screen. If you do want to chat with us, you can feel free to give us a call, add us on WeChat, um, or stick around. I'm going to just stick around and answer some questions, but we'll probably end the live stream and any recordings here. And anybody who is finished and you've heard everything you need to hear, you have all the information you need, feel free to hop off. Thank you so much for coming and taking the time to hang out with us and asking great questions. And have a great night, everyone who is hopping off. I'm gonna answer the most recent question that just came in.
Yeah, let me launch the exit poll very quickly.
To answer Danny, we offer classes online, in person, and most of our offerings are group classes, but we also do offer one-on and tutoring.
Yep, like Kelsey said, we can always schedule a meeting with us. And here we have the free trial QR code and our WeChat QR code. And our contact information.
Currently, our only in-person offerings are in Lexington, Massachusetts, unfortunately. But we have been working on partnering with some schools, so we can always look in that area. And I think if you have a student with us, then we will already have your information. But if you don't, we can always email you after this to keep the conversation going.
If there's no other question, I'll just stop sharing here.
All right. Thank you guys, and I hope everyone has a good day.
All right, I'll end the meeting.